Okay, so here we are at lesson 6, and in this lesson we're going to work with relations that are functions. Now remember, functions, the rule is if you want to determine if it's a function, for every input or x value you can only have one output or y value. You can have several x values for each y value, but only one y value for each x. Sorry, I said that wrong. For every x value you can only have one y value. So what that means is you could have, for a certain y value, you can have more than one x value. The easiest way to see it on a graph is the fact that if you draw a graph, if you use the vertical line test, then it'll only pass through the graph once. Meaning for every x value you can only have one y value. A function is a relation in which each element of a set A is mapped to one and only one element of set B, meaning the output value. So here we can see this is having the numbers A goes to B by dividing by 2. Now again, this x value only has this y value. This x value only has this y value. It's not going to more than one value. There's not an arrow going from here to 4, but also going to 9. So let's see what else. Further down here, the inverse of a function. Basically, this is the inverse of the ones above. Instead of having, we're going from B back to A, where actually this is double A. Let's scroll up. Yeah, we were doubling here, or A is half of B, and here we're saying B is double A. The inverse of a function is a relationship which undoes what the function does. So it's just like your keys on your calculator. If you go shift, it basically undoes what the regular button does. So x squared, if you do shift x squared, it usually means you're square rooting. So those are inverse functions. Referring to the cases above, complete the following by choosing the correct answer. In case 1, so let me just get my pen here. In case 1, the inverse is or is not a function. So in case 1, is the inverse a function? Well, this is the inverse, and only for every x value there is only one y value, so it is a function. In case 2, is this a function? Well, for every x value there's actually more, or is there? Well, this is going to negative 2, that's negative 2 there, and 2. 9 is going to negative 3 and 3, so there's more than one output for every x. So this is not a function. The domain of the inverse is the range of the original function. And as I mentioned in class, to get a coordinate of the inverse function, you simply take the x and y values of the original function and switch them. The range of the inverse is the domain of the original function. So just read that over, and hopefully you'll make sense of it. The inverse of a function may or may not be a function. In other words, as I mentioned in class, here's your function, and if you have the inverse, it will look something like this. Probably should pick another color, but that would be the inverse of this. Now, vertical line test tells you that this is not a function, so sometimes inverses are not functions. I'll just scroll down here and clear first of all. Okay, class example 1. Consider the operation of putting on your socks, then putting on your shoes. What would be the inverse operation? Well, the inverse operation would be taking off socks, socks off. No, is that right? I'm putting on shoes off. Scratch that. Shoes, obviously first. Shoes off, then socks off. Okay. Complete the table to describe the inverse of the function. So if you're multiplying by 2, the inverse, whichever function undoes that. So multiplying by 2 means you would multiply by a half. Or of course you could say divide by 2. Is the inverse a function? Well, here you're taking x and multiplying by 2. Fair enough. So y would equal 2x. Here y would equal a half x. So that would be a function. So yes, it's a straight line. You're squaring, so you're taking x squared. So the inverse would be the square root of x. Is that a function? Well, we all know by now, hopefully square root of functions look like this. So vertical line, yes. Taking the reciprocal, so 1 over x. So 1 over x, what does that equal? If we're taking, what's the inverse of the reciprocal? I guess it would be flipping it again. So taking the reciprocal again. In other words, 3 over 2. Take the reciprocal, you get 4 over 3. How do you get that original value back? You flip it again. So 1 would take 3 over 4, and it would go to 4 over 3. But to do the inverse, you have to take the reciprocal again. Okay, so the reciprocal is actually the inverse of this original reciprocal. Is this a function? What do reciprocal functions look like is the question. Reciprocal of a reciprocal. Well, in this case, it is. Answer is yes. And I'm just actually thinking about this, the reverse of this. Again, if this is a function or not. That's the actual square root. Sorry, our original function for this is x squared. So we know x squared looks like this. So the inverse would actually look like that. So no, that should have been that should have been no. Divide by 3, then add 1. What does that mean? We take x, we divide by 3, we add 1. The opposite would be we'd have to subtract 1 and then multiply rather by 3. Is the inverse function? Is this a function? Well, you have to think about that, but yes, it would be. If you're taking x, you're subtracting 1, that would look like you're taking x, you're taking away 1, and then the whole thing gets multiplied by 3. So yeah, that is going to be a straight line, 3x minus 3, so yes. Okay, I'm going to leave it there for that part of the lesson, and I'll record a second video